stimulus. And our initial stimulus is a threshold stimulus, or a stimulus that gets us to that -55, okay? And then the next thing that we see is the depolarization of the membrane. In other words, the opening up of the voltage-gated sodium channels, specifically the opening up of the activation gates on those channels. Remember, at rest, the inactivation gates are open at rest. And so if I have a strong enough stimulus, all that needs to happen is I open up the activation gates and the channel is now open. So that allows me to depolarize the membrane, and that's created by the opening up of the sodium channels. Again, specifically here, you can probably put this in your notes, specifically the activation gates. That creates an increased membrane permeability to sodium as sodium begins to rush into the cell. And then that allows for a net positive membrane potential change. So all this is pretty much saying the exact same thing. Sodium rushes in, membrane potential becomes more positive. That is considered a depolarizing or depolarization event. Now there's a positive feedback here. This is what we mean by that regenerative mechanism. As soon as I open one sodium channel, open one voltage gated sodium channel, that creates the environment, that creates, remember, opening up that channel actually makes the membrane potential more positive. So in doing so, I now create the environment where I have a stimulus that's greater than -55. And so other channels that are closely associated to this initial channel now have their threshold value met, and they can now open up and now allow for more sodium movement. And so this is what makes this a positive feedback event. Opening up one voltage-gated sodium channel opens up many more, and that just moves us further and further away from -70, which is our set point. Okay, now another thing that happens as a part of the timed component of the inactivation gate is that that 1 millisecond timer went off. Remember, the inactivation gate is voltage and time sensitive, or voltage and time dependent. And so when we get to that -55 threshold, there are two signals that are sent off. One is that we've gotten to that voltage. Two is that after 1 millisecond, I'm going to close the inactivation gate. All right. And so that 1 millisecond delay is set into effect. That creates the closure of our sodium channel inactivation gates after that time has expired. And then that is what reverses the membrane permeability, right? So now we have the membrane permeability to sodium being decreased. It's not included here, but make sure you put that down arrow. Oops. Make sure you put that down arrow here to show that the membrane permeability for sodium is now decreased here. And that decreases the amount of sodium flowing into the cell as those channels close. And that is what changes the membrane potential direction, right? We now see no flow of sodium, right? Don't be confused and think that sodium starts to flow in the opposite direction. That's not what happens. Sodium just stops flowing, okay? As we close those channels, sodium stops flowing, and that contributes to the repolarization as well. But then the more important event of repolarization is going to be that 1 millisecond timed component of potassium channels. So we spoke about the fact that potassium channels were a lot more straightforward. They only have one gating mechanism, but it's both voltage and time sensitive, okay? So after that 1 millisecond delay, we're gonna open up our potassium channels. They are going to, remember, they're also opening up at that positive 32, right? They're also voltage sensitive. And then we're gonna see an increase in the membrane permeability to potassium. So let's put that increased arrow here. I don't know where this arrow went, but this is what should happen. Oh, this is a flow chart. So it's going to keep moving the arrows, but make sure you put those arrows in on your notes, okay? So we increase membrane permeability for potassium. That allows more potassium to flow out of the cell according to its ECDF. And then that is also going to contribute to the repolarization, okay? This is now considered a negative feedback because as potassium begins to move, we now reapproach or restore our resting membrane potential as we get back down to that -70, that resting value.